Hello, my pre-calcers. This is Mr. Wilmuth back with another round of conic sections. We talked about parabolas in 8.1. Today we will talk about ellipses in 8.2. So I strongly encourage you to open up that online book and follow along on 8.2. It's going to have all of the formulas and all that stuff that you'll need for ellipses. Okay, an ellipse is a set of all points in a plane. We're going to have foci, focal axis, center, vertices. So it's going to look kind of like an oval. Is what an ellipse. You got your center, your vertices, your focus. Your focal axis is the longer one. So, on an ellipse, you've got to put, if it's this way, that means it's the x squared first because this has to be bigger. The bigger value on the bottom, that's always going to be your a value. So if it's bigger under the x, that means it's this way. If it's bigger under the y, that means it's this way. Okay, so then we've got a whole bunch of different things here. Pay attention to the Pythagorean relation in an ellipse. Sometimes they'll give you C and you got to find A, B, whatever. So you got to use that Pythagorean relation. It's a little bit different than Pythagorean theorem when you're dealing with an ellipse. It's A squared equals B squared plus C squared. Okay, so there's a x squared first ellipse. There's a y squared first ellipse, vertical, major axis, all that stuff. Yeah. All right, let's try it. Find the vertices and the foci of an ellipse. 9x squared plus 4y equals 36. Well, I need to get this equal to 1, so I'm going to divide this by 36, everything. That gives me equals 1. 9 over 36 is x squared over 4, because 9/36 is 1/4, and 4 over 36 is y squared over 9. Now, 9 is bigger, so I actually need to flip those two around so we don't get confused. So this is actually going to be a vertical ellipse, and I always just like to write those in the same order. Okay, so vertical ellipse means you look at your cheat sheet there, you look at your notes in the book, and we can see that to find the vertices, those are going to be 0, plus, and minus a. The foci are going to be 0, plus, and minus c. Okay, so, well, we know from the top, a squared equals 9, so a is 3, and b squared equals 4, so b is 2. Take the square root of both of those to get your ab. So we've got a, we've got b. We're going to need c to finish this. Well, that you got to look down at your Pythagorean relation. It's a squared equals b squared plus c squared. So a squared is 9 equals b squared is 4 plus c squared. Subtract 4 gives me 5 equals c squared. Take the square root, and you can leave them like this. C would be the square root of 5. Okay? So our vertices are 0, positive a, which is 3, and 0, negative a, which is negative 3. Our foci are 0, square root of 5, and 0, negative square root of 5. Okay? Make sure with the ellipse, the bigger one comes first, and if it's under the y, it's vertical. If it's under the x, it's horizontal. Okay? All right. Follow your sheet. Like I said, these are all located in section 8.2 of your online textbook. All right, let me see what we got here. Find the equation of an ellipse whose foci are negative 2, 0, and 2, 0, and whose minor axis has a length of 2. Okay, so I got to cruise back to my thing here. It says they're negative 2 and 2. Those are coming first, so that means this is an x ellipse. That's going this way. So I'm looking over here, and so it says the foci is plus and minus c. So we know our c is 2. Okay? It also says that the minor axis has a length of 2. So that's a this way ellipse. So this has a length of 2. So half of that would be 1. And that would be the minor axis length of 2. Hold on here. Been a while since I've looked at this stuff. Oh, the minor axis is B, so it's just 2. So B is 2. So no, it's a semi-minor axis. Yeah, I was right. So it'd be 1. Sorry about that. So if the axis is a length of 2, according to the notes, the semi-minor axis is B. So you got to take half of the minor axis, which would be 1. All right. So all we're missing here is A. So we've got to use our Pythagorean relation. A squared equals B squared plus C squared. Well, A squared equals C squared is 2, B squared is 1. C squared is 4, B squared is 1, so that's 5. So A equals the square root of 5. Okay? So remember now, we're looking at x squared over A squared plus y squared over B squared equals 1. We need A and B to write the equation. X came first because of the y being 0, so we knew to look there. So x squared over A squared would be 5. The square root of 5 squared is 5. Plus y squared over B squared would be y squared over 1 equals 1. Sorry for butchering that problem. I got a little mixed up with this, but that's why we've got the notes. So A, B, C. So A should be bigger than B when you do this. All right, so that is if you have ellipses that have vertices of, the center is at 0, 0. Here's the alphabet soup and all the stuff for if the equation is a center of HK. So we're going to move it somewhere besides 0, 0. A lot of the stuff is the same. This is in the book on 8.2. Make sure you check that out. Pythagorean relation is still the same for an ellipse. Bigger number still comes first in the ellipse. Just realize that H goes with X and K goes with Y. You got everything you need right there. Okay, so if you look at that, there's X squared first ellipse. On the right is a Y squared first ellipse. Okay, find the standard form for the equation for the ellipse whose minor axis has endpoints -1, 4, and 5, 4, and whose major axis has a length of 8. Okay, so we can see here on the graph that we've got a center that's right here. So that's at 2, 4. So H is 2, K is 4. All right, so this is a vertical ellipse, so we're going to use the y is going to come first. So y minus k squared plus x minus h squared over a squared over b squared equals 1. All right, we've already got h and k. We need to find a and b. But this is the major axis. So if you look on there, on the vertical side, the semi-major axis, so half of the major axis is the bigger one, is your a value. Well, what's half of 8? That's 4. So a is 4. Your minor axis is this way. That's 6. So half of it is your b value. That's 3. We don't even need c to write this equation. We've got a, we've got b, we've got x, or k and h. So y minus k squared over a squared would be 16 plus x minus h squared, which would be 2, over b squared, b is 3, is 9, equals 1. Ellipses are a little bit easier than parabolas. Just remember that the bigger a value has to come first, and that determines whether it's under an x or under a y. If it's under an x, then it's a this way ellipse. If it's under a y like this one, then it's a vertical ellipse. Okay, that is it for ellipse. Oh, we got one more. Find the center and vertices and foci of the ellipse. All right, let's do it. Let me get this equation filled in here for us. x plus 1 squared plus y minus 1 squared. Okay, so this is an x first ellipse. Or no, it's not. They flipped it around on us. So we've got to make sure that we're just going to rewrite this. 9 is bigger than 4. So we got to go y minus 1 squared over 9 plus x plus 1 squared over 4 equals 1. I guess it doesn't really matter if you flip it around. You just know that a squared has to be 9. So a is 3. B squared has to be 4. So b is 2. H is with the x, and it's the opposite. So h is negative 1. K is positive 1, because you do the opposite. All right, we've got H, K, A, B. We're going to need to find the center, vertices, and foci of the ellipse. So center, vertices, foci. So y is bigger, so we're going to go to our notes. We're going to be on the right-hand side because y is bigger. It says center. Well, we've already got that. That's negative 1, 1. Okay, HK, center. Vertices. Those are H, K plus and minus A. All right, well, H is negative 1. We're going to have 2 of them. K plus A. Well, K is 1 plus 3 is A, and 1 minus 3. So 1 plus 3 is 4. 1 minus 3 is negative 2. So those are our 2 vertices, or crosses there. Okay? Your foci, it says H, K, plus and minus C. Well, H is negative 1 still. All right, we need C. Remember, Pythagorean relation of an ellipse. A squared, 9 equals B squared, 4 plus C squared. Okay? Subtract 4 is 5 equals C squared. Take the square root. So C equals the square root of 5. Seems to be coming up a lot. So K plus C would be, our K value is 1. 1 plus the square root of 5. And 1 minus the square root of 5. And you can leave them like that. Okay, so ellipse. There's a few